Calix here from Math Magicians. We will continue with our Precalculus course, always with the prerequisites for Precalculus. Our topic for today would be Cartesian Coordinate System. The subtitle will be the Cartesian plane. The first exercise says, draw a scatter plot of the data given in the table. Okay, a scatter plot is just a normal graph, X and Y graph. The exercise says, U.S. imports from Mexico. The total in billions of dollars of U.S. imports from Mexico from 2000 to 2007 is given in the table, okay, the table that you can see here. For that, we will change, we have to make a graph for this, so we will change our slide in which we have our graph here. Okay, I already copied the table, as you can see here. Let's change our color so we can see our graph different. It says, from the years 2000 to 2007, the U.S. imported from 135 and a difference from until 210.7. We have to make our table for this. The first number is always going to be your X. In this case, it will be the horizontal line. And the other one will be your Y, that in this case will be your vertical line. Okay, we're just going to use one part of the quadrant because every number is positive. We will start naming the years, okay? The year 0, I'll name it as 2000. This will be the year 2001, 2002, 2003, 4, 5, 6, and 7, okay? So we have our years. And the U.S. imports, we name them by 50s or by 100s, however you want to. This can be 100, 150, I'll name them here. 150, that means that this would be 200 and 250. Okay, that's all we need. Now, it says that the year 2000, U.S. imported 135. So, the year 2000, we just discussed that it was R0 here. And they imported 135. So, that number has to be somewhere around here. The year 2001, it was a little bit less. The year 2001, it was a little bit less. The year 2002, it was a little bit more, 135 and 34.6. Then we have in the year 2003, it says that it's 138.1. It's a little bit higher. The year 2004, 155.9. It's around here. The year 2005, 170. Okay, it's getting a little bit closer to 200. The year 2006, 188, a little bit closer. And the last year, that is 2007, it says that is 210 point. And this would be your scatter plot. With this, we'll continue with our next exercise. The next exercise discusses about absolute value of real numbers. You can see the absolute value real number definition here. And you can also see properties of absolute values. Okay, one thing that is very important is that if a number is negative inside an absolute value, it will always be positive because you just multiply a negative sign to it. With this in mind, we will answer these two. Okay, letter A says, what is the answer of the absolute value of -4? This is like saying negative times -4, which is actually 4. And this will be your answer for letter A. Letter B, let's change our color, is a little bit different. Negative times pi minus 6. It's like this. If you multiply the negative as if it was a distributive property, this is like saying 6 minus pi once you multiply your negatives. If you calculate this in your calculator, it will be around 2.86. So here we answered letter A and letter B of the absolute values. We will continue with the next part of the video. This will be the distance formula. Okay, the distance between any 2 points, in this case P and Q, in the coordinate plane is this one here. This is your distance formula. x1 minus x2 to the square plus y1 minus y2 to the square. If we solve this exercise that says find the distance between the points, and we name these points as x1, y1, x2, y2. The order in which you put them doesn't matter, okay? The only thing that you have to follow is that the x always goes first, and the numbers have to be together, the 1's together, the 2's together. If we substitute this information in our formula, we'll have that the distance is equal to the square root of -3 minus 5 to the square, plus it will be -1 minus -1 everything to the square. Okay, we complete our square root this way. If we evaluate this, d is equal to the square root of, the addition of this will be -8 because they're both negatives, you add them to the square, and this is like saying -1 plus 1 to the square because negative times negative is positive. We know that this is 0, so we just have that d is equal to the square root of -8 to the square is -8 times -8, which is positive 64. Okay, as you can see here, that means that your final answer will just be the square root of 64, that is equal to 8. With the next type of exercise, it says find the area and perimeter of the figure determined by the points. Okay, so if it gives you 3 points, let's assume right now that it's a triangle, and we need to find what is the area and perimeter of the triangle. There are two things that you need to remember. Okay, the perimeter, you just find it by adding all its sides, and the area is found by base times height divided by 2. Some of you just put 1/2 base times height. It's also correct. So let's start finding what are the distances so that we can find the perimeter and area. Okay, so I'll name this as distance 1. Distance 1 will be these two that I'm going to circle in blue color. So we know that our distance formula is the subtraction of the x's plus the subtractions of the y's, everything inside square roots and inside square powers. In other words, it would be -5 minus 0 inside a square power, plus we open another parenthesis and it will be -3 minus -1. I'm sorry, 3 minus -1, not negative. And we close it to the square power. If we evaluate this, our distance 1 is equal to the square root of, this will actually be -5 to the square, that is just 25. You can use your calculator for this also. And this is like saying 3 plus 1, which is 4. 4 to the square would be 16. We make our addition of these two numbers. Our distance 1 says that is the square root of 41. Okay, so we did distance 1 already. Now we're going to change our color to make distance 2. For distance 2, I'm going to use this parenthesis or this point and this point. So distance 2 says is equal to the square root again. And now it would be 0 minus 4 to the square power. Remember the orders. x1 minus x2 to the square plus y1 minus y2 to the square will be -1 minus 4 to the square. If we evaluate this, the first one is -4 to the square, that is 16. And the second one is -1 minus 4 is -5 to the square, that is 25. This one is also the square root of 41. We found distance 1 and distance 2. Now we need to find what is distance 3. For that, we're going to change our color again. And distance 3 would be the first point with the last point. As you can see, we combined all the points. So I'll try to make distance 3 here is equal to the square root of, in this case, it will be -5 minus 4. Following our formula, do not forget that, to the square, plus, and then we have 3 minus 4, also following the formula, to the square. If we evaluate our distance 3, it says that is -5 minus 4 is -9. To the square would just be the 81. And then plus 3 minus 4 is negative 1. 2 to the square is 1. If you evaluate this, is the square root of 82. So there you have all your distances. The perimeter, you find it by, we'll do it in blue color again. The perimeter, we find it by adding all the sides. So it would be the square root of 41 plus the square root of 41 plus the square root of 82. It's like saying 2 times, because you can add square root of 41 and square root of 41 plus square root of 82. So that would be your perimeter. If you want to find it as a decimal, use your calculator for this. It will be 21.86. So here we found our perimeter. Now we need to find our area. So I'll change my slide to find the area. The formula to find the area is base times height divided by 2. I do have a base, that is the bottom part, because if you make your triangle, it would look like this. Square root of 41, square root of 41, and square root of 82. This is actually my base. What I don't have is my height. I need to find this height. But if it's an isosceles triangle, there's an easy way to find the height. There's also a formula for it. It says that height is equal to the s, that stands for a side, to the square, minus the base over 2, also to the square, and everything inside square root. This is the formula to find your height of an isosceles triangle. If you substitute the information that you have here and solve, you can solve with your calculator. This is 41 here. You can solve with your calculator. It says the square root of 41 to the square minus the base, that is the square root of 82, over 2, also to the square. And you evaluate this in your calculator. It will tell you that your height is equal to the square root of 41 minus 20.5. Once you solve this, if you subtract and evaluate your square root, it tells you that it's around 4.53. That would be your height. Once you have your height, you go back to your formula. Let's change back to blue. So we go back to our formula. It says area is equal to the base, that was square root of 82, multiplies your height that you found, that is 4.53, and this divided by 2. If you evaluate this in your calculator, your final answer is 20.5 as an area. There you found your perimeter and your area. With this, we will continue with our next part of the video. So we already saw distance. Now we're going to find midpoint. The formula to find a midpoint is this one here. I like to use, see it this way: x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Just because I order my points with x and y. So if we have that formula and we say that this is x1, y1, x2, y2, and we organize them with the midpoint, we will have negative 7 over 3 plus 5 over 3 divided by 2, comma, because it's a point, 3 over 4 plus negative 9 over 4 divided by 2. Okay, we have this. If we start evaluating, because they have the same denominator, we can say that negative 7 over 3 plus 5 over 3 is negative 2 over 3. And then 2, but I like to put a 1 under it because I'm going to use what we call the year operation, comma. We can do the same thing in the other side, 3 minus 9, because negative times positive is negative. So 3 minus 9 would be negative 6 over the same denominator over 2 over 1. Okay? Remember that I told you something called like a sandwich. Okay? We make what I like to call the year operation. If you evaluate, multiply those numbers, the outer and the inner numbers, your midpoint becomes negative 2 times 1 is negative 2. over 3 times 2 is 6, comma. Negative 6 times 1 is negative 6 over 4 times 2 is 8. Okay, so now what we have to do is simplify these points. M is equal to negative. We find the half of them. Sorry there. The half of 1 is, the half of 2 is 1, and the half of 3 is 6. Of 6 is 3, sorry. And then we have the half of 6 and 8. The half of 6 would be 3, and the half of 8 is 4. So your answer would be negative 1 over 3, comma, negative 3 over 4. With the next type of exercise, we will start with the equations of circles. You have the definitions of standard form equation of a circle, as you can see here. Okay, you have your center, that is h comma k, and you have your radius that is specifies, as it specifies in the equation, is r to the square. So we're going to start with the first exercise that says find the standard form equation of the circle. And the first one, letter A, says that the center is negative 4 comma 1. That means that your first point is h and your second point is k, as specified in the standard form equation. And the radius, it says that is 8. If you copy this in your formula, it says that x minus, in this case, h is negative 4, everything to the square, plus y minus, in this case, k is 1, is equal to the radius, that is 8 to the square. If we evaluate our negative signs and this is to the square here, if we evaluate our negative sign here and our power here, we will have that x plus 4 to the square plus y minus 1 to the square is equal to 64. And that would be our answer for the first equation. Now, for the second one, we have a center of 0 comma 0. Okay, our center 0 comma 0. That means that we can eliminate our h and our k. We will just have, this will be for letter B, x to the square plus y to the square is equal to the radius, that in this case the radius is 5, so it will be 5 to the square. Your answer or your equation is x to the square plus y to the square is equal to 25. This would be your answer for letter B. Let's change our colors so we can do the next type of exercise. The next one is just asking for find the center and the radius of the circle. The center is your h and k, but it's always going to be the inverse sign. Why? Because of the negative sign that you see in your formula. So your h and k, if you put it as a point, would be negative 4, comma, 2. Always the opposite sides. Sign, sorry. And r to the square is equal to 121. If you solve for r, you send the square power as a square root, is at the square root of 121 is equal to 11. So there you have your center and your radius for this type of exercise. Okay, with this we'll continue with the next type of exercise. That is for application. It says write the statement using absolute value notation. Okay, just using absolute value notation. The distance between x and c is less than the unit. So it's as easy as this. The distance between x and c is less than the units. And this is your answer as an application. That would be it. Let's continue with the next type of exercise. The next one says, use the converse of the Pythagorean theorem and the distance formula to show that the points negative 3 comma 4, you can see it here, 1 comma 0, and 5 comma 4 to determine if it's a right triangle. Remember that to determine if this is a right triangle, it has to satisfy Pythagorean theorem. It says c to the square is equal to a to the square. Let's fix this. And we have this problem again. Let's fix it again. A to the square plus b to the square. Okay, so you have to follow that form. C to the square is equal to a to the square plus b to the square. To find that, we need to find what are the distances of each one of them. The same thing we did in the last exercise. Distance 1 is equal to Okay, here we're just going to start working on them directly. The square root of, in this case it will be negative 3 minus 1 to the square plus 4 minus 0 to the square. If you solve this, you can use your calculators. It will tell you that it's the square root of 32. You can simplify, but let's leave it this way right now. Let's change our color to find the distance 2. The distance 2, you choose another 2 points. You can use this too. It says 1 minus 5, following the distance formula, to the square, plus, then we have, I'm sorry, it's not 1 minus 5. Yes, 1 minus 5. Then we have 0 minus 4. That is this one and this one here. 0 minus 4 to the square power. If we evaluate the distance 2, it says that it's also the square root of 32. From here, we can determine that it can be isosceles, okay? It can be isosceles, but we need to find if it's a right triangle. Then we use the last point. Let's use another color. Distance 3 is equal to. Now we're going to use the other 2 points. In this case, will be the first and the last point. So it will be negative 3 minus 5, square root of negative 3 minus 5 to the square, plus, and then it will be 4 minus 4 to the square. We know that this is 0, so we're just going to evaluate the other one. It says negative 3 minus 5 is negative 8 to the square will be square root of 64, and we know that the square root of 64 is 8. Since this is the greatest number, this will be our C. And if we evaluate now to check if it's a right triangle, 8 to the square is equal to, this can be A, this can be B, square root of 32 to the square using Pythagorean theorem, plus square root of 32 to the square. We know that this cancels, 32 plus 32 is 64, and 8 to the square is also 64. We can say that it is a right triangle. Okay? With that, we'll continue with the next slide. Now, this will be the last exercise for this topic. So it says that prove that the figure determined by the points is an isosceles triangle. Remember that for it to be an isosceles triangle, 2 sides have to be equal. Okay, so we need to find what are the distances between the points. The procedure is basically the same. We will find distance 1 between point 1 and point 2. Let's call these ones like that. So it will be the square root of 1 minus 4 to the square power plus 3 minus 7 also to the square power. If you evaluate those subtractions and the square powers, and you just leave it inside your square root, it will tell you that is the square root of 25, because it will be 9 and 2. Yes, it's correct. That answer here would just be 5. Now, for distance 2 now, let's change our color. Distance 2 says the square root, now we're going to use the second and the third point. So it will be the square root of 4 minus 8 to the square power plus the 7 minus 4 also to the square power. If we evaluate our distance 2, it says that it's also the square root of 25, which we know that is 5. And the last distance, we're going to do it in blue color. The last distance will be D3. It's my first point and my last points, the 2 points that I'm going to circle. It says the square root of, in this case it will be 1 minus 8 to the square power plus 3 minus 4 to the square power also. If we evaluate this one, is the square root of 50, that if you simplify it, it will be 5 square root of 2. As you can see, because you have two equal sides and a base that is greater than the two sides, we can say that it is isosceles. With this, we are done for this topic. And don't forget, math is magic.